This is the final exam review for fall 2019 for statistical reasoning. First period, you would take your final on Thursday, unless you are taking the U.S. history or economics EOC, then you would take yours on tomorrow or Friday, or maybe Thursday afternoon, whichever one you want to decide. But we're going to go through this real quick. I'm going to just show you some answers and how I got it and explain it. And then you can pause the video anytime you need to write down the answers, to go back and or listen to it again to see the understanding. The main thing is to make sure you understand the process, not just writing the answer down. Alright, so number one says, which of the above dot plots has the greatest standard deviation? Oh, sorry, it's greatest. I thought it said least, so the greatest standard deviation would be the other one. This one is the actual correct answer here, because greatest standard deviation would be the one that's spread out the most. This is the least standard deviation over here on the left, because it is bell-shaped. Alright, so I made a mistake there on number one. The right graph is the one with the greatest standard deviation. The left graph is the least standard deviation. Number two, you'll see I made a little table over here for before side and the after side. And if you notice, this is a back-to-back stem and leaf plot. So remember, that's really 68, 68, 69, 70, 71, 104, 110. And on the other side, is that 10, 0, 4, 4 would be 100, 104, 104. The 11, 8 would be 118. The 12 and 4s would be 124 each. Alright, now, in order to put the information in the calculator, you press Stat 1 and type your information in L1. You do one side at a time. You have to type it in like 68, then 68, and then 68, and then 69. Alright, so after you get your data in L1, just the left side, do before first. You press Stat, go right, and then go to one variable statistics. Then you're able to enter, go make sure it says that frequency list is nothing's there on that second one. You should have L1 on the first one, nothing on the second one, and go down and calculate. And it should give you this information. These are the symbols. Mean, median is MED, standard deviation SX, IQR is Q3 minus Q1, range max minus min, and then shape we get from looking at this information. That looks skewed left, but remember the tail is where the high numbers are. On the number line, the higher numbers are on the right, so it will be skewed right. Alright, so you write in that information. That's the information for before. 80.7 is your mean, 76 your median, 12.6 your standard deviation. Q3 was 88 minus Q1 70, 18. Max is 110 minus 68 is 42. It was skewed right. Alright, then you go back, clear out your data, Stat 1 for edit, and type in your data in L1 again, but this time do the after. Remember, that's 86, 87, 88, 88, 90, 92, 92, so on and so forth. Get all your values for the after. You'll see that the mean is 101.5, median 98, standard deviation 15.9, Q3 104 minus 90 is 14, range 146 minus 86 will be 60, and skewed right. So these are the values for before and after. And you compare them, you see after's got the greater mean and standard deviation, and the greater median. The IQR is greater for before, but the range is greater for after. They have the same shape, skewed right. So that's how you would do number two. If you need to pause it to get a good look at it, that would be fine. Q3, no, not Q3, number 3. The lights are getting a little dim here, hold on, sorry. Number 3, we have here, this is a box and whisker plot. Remember, that's your min. This down here is your max, Q1, median, Q3. Same for second period, min, max, Q1, median, Q3. And they just want us to do the same kind of stuff we did on the last problem. The range will be your max minus your min. So for the first period, you see the range there's 37.5. Second period, 25. I just got the max and min from the picture over here. The median is the line in the middle of the box. So you can see 80, 85, second period has a greater median. IQR, that's the ends of the boxes. Subtract Q3 minus Q1, 15 and 11. So first period had the greater IQR. And then the minimums, the left point, that's connected to the box. And first period had the smaller minimum. And then the amount of scores about 80. So 80 is right here on our number line. Well, that's the front of the box for second period, so that's the first quartile Q1, so that would be 25%. But it is the median for the first period, so that would actually be 50%. The median's in the middle, that's where 50% of your data would be. So that's why first period is 50%, second period will be 25%. All right, number 4 is our relationships between the mean and median based on the shape of the graph. Remember, skew left, the mean is less. If it's symmetric, the mean and median are equal. If it's right skewed or skewed right, the mean is greater, because remember the mean, the skewed tail pulls the mean down because there's outliers on that end, or really significant, like large values. So that's what pulls the mean that to the direction of the tail, while the median stays right there near the middle of the hump. So draw those pictures, and you just need to know that relationship. All right, on the back, number 5, it says describe how standard deviation relates to the distribution of a graph. Standard deviation describes the spread of the data. It tells you how far apart your data is spread from the mean. Number 6 wants to know the formula for outliers. There's your formula for outliers, both of those. Remember, if it's below this number, it's an outlier, or if it's above this number, it will be an outlier. To find the IQR, you do Q3 minus Q1. 12 minus 5 is 7. I even added it to the table over here. And which of the following will be outliers? I plugged the numbers into the formula. I got negative 5.5. Plugged them in for Q3 plus 1.5 times 7. Got 22.5. And there's 2 outliers, 23 and 30, because they're both above 22.5. None of those values are lower than negative 5.5. So our only outliers are 23 and 30. Number 8 says, explain why we use median to compare center and interquartile range to compare spread. If a data set has outliers, it's because the median and IQR are not affected by outliers. That's why we use those. Mean and standard deviation are affected by the outliers because they pull the mean down and spread out the data. Number 9 is talking about categorical and quantitative data. Categorical data is basically categories described by words more than numbers. They don't have any value to them. While quantitative is data that has value. It tells you like how much. So some examples would be categorical would be like favorite color, gender, while quantitative will be like height, weight. So those are some examples of categorical and quantitative data for number 9. Number 10, it asks you, is a teacher correct when she says that the greater percentage of students with brown hair than with brown eyes? So what you have to do is find out how many students have brown hair, 28 out of 60. How many students have brown eyes, 23 out of 60. And you would see that, do the math to figure out the percent. Brown hair is 47%, while brown eyes is 38%. So yes, the teacher is correct because brown hair has 9% more. That will be number 10. So in a two-way table, it's usually just making an assumption and determining if that assumption is correct or not. That's what that is, a two-way table, because it gives you hair color going one way, up and down, and then eye color going across. Number 12, this is linear regression. This is where you put it in L1 and L2. So stat edit, put height in L1, weight in L2. Height's your explanatory. The taller you are, probably the more you would weigh, usually. All right, now stat, calc, and go over to 4 once you get your data in. Stat, go right to calc, and you go down to 4. Linear regression, AX plus B. It's important that you get the AX plus B because A will be beside X and B will be the constant. So here you see our A is 2.9, our B is negative 53.3. I went ahead and wrote R down, 0.99886. If for some reason your R doesn't show up, you make sure you go to Mode in the calculator and scroll up until you see Stat Diagnostics and make sure it's on. So if your R didn't show up, hit Mode, go to Stat Diagnostics, and turn your Stat Diagnostics on. So we just plugged A and B into the formula AX plus B. You get Y equals 2.9x minus 53.3. That is your linear regression or least square regression line equation. The correlation coefficient is R, which was 0.99, and I just went ahead and rounded that to a 9. And the strength and direction will be strong positive. The relationship will be as height increases, weight increases as well. Alright, so that's the linear regression. Number 13 is wanting you to use this computer output to determine the least square regression line equation and interpret slope and y-intercept. If you look right here where it says response variable is GPA, that's your y. Remember, response variable is y. The constant is going to be your b, and time spent studying is going to be your explanatory variable, your your x, and then the a is the coefficient of the x. So it'll be GPA, that's your y, for y equals ax plus b. GPA is y equals a is 0.5, x, remember, is time spent studying, so I just put study time, plus b, 1.2. The other three columns, these don't even matter. We don't even use those. And we don't even use any of this down here at the bottom. You could use r squared to figure out what your r is, but we didn't go that far with the computer outputs. To interpret the slope, he says as study time increases by 1, that's if this goes up by 1, that's going to be 0.5 times 1, then the GPA will increase by that 0.5. That's how you interpret the slope. If this number increases by 1, then the GPA is going to increase by 0.5 the slope. To interpret the y-intercept, that's when you just have 1.2, so that means when study time is 0, the GPA will be 1.2, your y-intercept. So that's interpreting slope and y-intercept there. D, use the equation to make a prediction. If a student spent studying 3.5 hours, you just take 3.5, plug it in for your x into your equation up here. Or study time is 3.5, so 0.5 times 3.5 plus 1.2, you get a GPA of 2.95. Alright, down here it says what are 6 types of surveying samples. You can write them in. You have simple random sample, stratified random sample, cluster sample, voluntary response sample, convenient sample, and for some reason I can't think of the 6th one at the moment. But I'll make sure you have it first thing in the morning. Right, last one. Flip over to the back. You have biased and unbiased sample. Here's a bias is asking basketball fans their favorite sport. Unbiased will be asking people at the mall their favorite sport. Difference is biased kind of leads you toward a certain answer. So if I want people to say basketball is their favorite sport, I go to a basketball game and ask those. But if I want an unbiased sample, I would just ask anyone in particular that I see at a mall, or maybe people walking in the lunchroom, but just not at a specific sporting event if I'm trying to get that type of answer. Number 16 says, give an example of a biased question. What do you think of our great principal, Mr. Williamson? That would be a biased question because I said a great principal. That's a leading question, kind of wanting you to say a certain answer about Mr. Williamson being great. Remember, that's the type of biased questioning. We also had double barrel questions, leading questions, things of that nature. Even when the type of language that they may use to persuade you might just make you not even know what the question's asking because they may put a lot of big words or something in there. That would make it be a biased question as well. All right, now number 17, we have these correlation coefficients, but remember, the sign doesn't matter. The sign just tells you whether it's going to be positive or negative, whether the data values are going up or going down. What the strength is the decimal. The closer it is to 0, the weaker it is. The closer it is to 1 or -1, the stronger it is. So you see those are put in order from least to greatest, pretending like the signs are not even there. and then you can just put the signs back on them after you put them in order from least to greatest. Alright, and the last one wants you to draw some pictures. Strong negative. Strong negative means it's going down and they're close together. Weak negative means it's going down but they're spread out a little bit more. No correlation means the dots are just all over the picture. Strong positive, they're kind of in a line going up. Weak positive, again, they're going up but they're scattered a little bit. So that's just a quick review of our final exam review. Remember, first period, you'll take it on Thursday unless you're taking an EOC on Thursday. Then we'll try to work out a time. Either you can take it tomorrow if you would like, or on Friday if you have a chance to, Friday or Thursday afternoon. So good luck studying. Sorry that it's late, but you really don't need it until tomorrow actually, because you'll be working on this in Miss Miller's class tomorrow while I'm doing testing. So good luck studying.